In the last chapter, when we were studying the U.S. customary system, we studied weight, and we said the units for weight among them were the ounce and the pound and so forth. And we said that weight referred to or had something to do with the force of gravity, how strongly the earth is pulling objects to the center of the earth. Well, here we're going to talk about mass. Now, mass and weight are pretty much the same thing on the surface of the earth, but mass is really a measure of the quantity of matter of something. How much substance is there? Now, the real difference between weight and mass is this, that if you're on the surface of the earth, weight and mass are the same. But if you go out in space and you go to the moon, for example, then you weigh less. The force of gravity on the moon, the force pulling you toward the center of the moon, changes because the moon is less dense than the earth and a lot of other reasons. But, okay, so you're lighter on the moon, but there's not any less of you. If you were talking about how much mass that you have within your body, then it would be the same, you see. So mass doesn't change whether you're in space or on the surface of the earth, but weight does. So we're talking mass here in the metric system, and we can think of them interchangeably when we're talking about objects on the surface of the earth, and the primary unit for measuring mass is the gram. And just like in the last section when we applied prefixes to the word meter for measures of length, we apply the same prefixes to the word gram in order to create other measures, units for measuring mass. Now, not all of these are in common use. The most commonly used ones are kilogram, gram, and milligram. You might already know that when you read product labels, a lot of times fat content is given in grams. And when a doctor writes a prescription for some pills, those pills are measured in milligrams. Well, the gram is actually related to measures of length like this. The scientist that came up with this idea for the gram decided to make a cube out of a very tiny unit for length, the centimeter. And here's an illustration of a cubic centimeter. Now, this is actually larger than is really the case because a centimeter is just about this big. It's pretty tiny. It's less than a half an inch. But so this is kind of expanded a little bit just for illustration purposes. But if you take a cube that is 1 centimeter on every side and you fill it up with water, then the amount of water that is contained within this cubic centimeter is the mass, which is 1 gram. So 1 gram is the mass of 1 cubic centimeter of water. Well, we're going to go through some conversions, and let's just remember that kilo means 1,000 and milli means 1,000th. You see, and the others are as we depicted them before, but these are the main ones, the kilogram, the gram, and the milligram. Let's talk about conversions. Suppose we want to convert 324 grams into kilograms. So 324 grams is equal to how many kilograms? Well, once again, it's just a matter of sliding the decimal point, and we can slide the decimal point in a couple of ways. Now, the important thing about sliding the decimal point is how many places and in what direction. And we can use this little illustration to decide on both. If we're changing from grams to kilograms, we identify the position of the grams, the position of kilograms, you see, and from grams to kilograms, we have to slide to the left 1, 2, 3 places. So we're going to take this number and take the decimal point and slide to the left 1, 2, 3 places. Boom, it goes to the left of the 3. So we have 324. So that's the idea. If we have a handy illustration like this, it's pretty easy to tell how the decimal point is moved. Now, the other technique for making the conversion is this, that if we are changing from grams to kilograms, we say, oh, the kilogram is a larger unit of measure. When we have a larger unit, there'll be fewer of them, and we divide, therefore, to get fewer, and we're going to divide by the number of grams there are in a kilogram. Kilogram is 1,000 grams, so it takes 1,000 grams to make a kilogram. So we're dividing by 1,000. Divide this by 1,000, and the decimal moves 1, 2, 3 places to the left. So we get the same result as expected. Consider this problem. Suppose we want to convert 4.23 grams into milligrams. So we're going from grams to milligrams. And once again, we can use the illustration up here to help us with the movement of the decimal. Now, let me erase a little bit here. Okay, here we go. Grams to milligrams. Here's milligrams, here's grams. So we're going from grams to milligrams. That means we're going to slide the decimal 1, 2, 3 places to the right. So in this number, we take the decimal and go 1, 2, 3 to the right, and that makes this 4,230 milligrams. The other way to think about it is like this. We're thinking, well, we're changing from grams to milligrams. The milligram is a smaller unit than the gram. If we're changing to smaller units, there'll be more of them, so we'll have to multiply. We multiply by the number of milligrams in a gram. That would be 1,000. Multiplying by 1,000 slides the decimal 3 to the right. So again, we get 4,230. Here's that other kind of conversion that we talked about, the one where we have kind of a combined situation. We're converting 2 kilograms and 564 grams into a number which has to do with kilograms. So all of this goes into a kilogram kind of designation, and we already have some kilograms here. So here's what we're thinking. We're thinking we have 2 kilograms plus 564 grams. And we're going to change the grams into so many kilograms and then bring them back together. So that's the notion. So let's see, grams to kilograms. A kilogram is a larger unit than the gram. Larger unit, fewer of them, divide. Divide by the number of grams in a kilogram, that would be 1,000. Dividing by 1,000 slides its decimal 3 to the left, so we have 0.564. Bringing these back together, now that we have the same unit, you see, we bring them together, we get 2.564 kilograms. Here's another one. We're changing 209 grams and 42 milligrams into grams only. So again, we're thinking of it like this. 209 grams plus 42 milligrams. And we're changing this part into grams and then bringing them back together. So let's see, 42 milligrams into grams, going from milligrams to grams. Milli means 1,000th, you see, so a very tiny unit, into grams. Gee, we're going to a larger unit. There'll be fewer of them, so we divide. We divide by the number of milligrams in a gram. That would be 1,000. Dividing by 1,000 slides the decimal 3 places over. 1, 2, boom, 3. We need a 0 as a placeholder, so it looks like this. We usually put a 0 to the left of the decimal as well. Then we bring these two together. So it's 209 grams plus this portion of a gram. So it's 209.042 grams for the conversion. Here's a word problem. It says, how many kilograms of fertilizer are required to fertilize 400 trees if 300 grams of fertilizer are used for each tree? Now, there are a couple of things to keep in mind here in working all of the word problems, and you saw it before. And it has to do with, there are occasions when we have to make the units exactly the same. Now, this is not one of those cases because we're going to need to multiply the 400 trees, the 400 for the number of trees, times the 300 grams of fertilizer needed for each tree. So it's 400 times 300 that we need to multiply. We can't change the unit of tree into the unit of gram. There's no conversion for that. So it's not needed this time, but it's just one aspect that we need to keep in mind from time to time. The other idea is that there are circumstances when if we're changing to a common unit, that we have a choice of changing to the larger unit or a smaller unit. Now here we do kind of have that as part of this problem because it says how many kilograms of fertilizer do we need? And yet we're given an amount of fertilizer in terms of grams. You see, so the question might be, do we multiply 400 trees times 300 times 300 grams and get an answer for all of the trees in terms of a whole lot of grams? Or do we change 300 grams into kilograms to begin with and then multiply by 400? Well, it turns out that the answer is going to be right either way you look at it, but let's just realize that there are two ways to approach it. All right. In most cases, because the conversions are so easy in the metric system, it's preferable to change to the larger unit first. Now, in the U.S. customary system, it's kind of debatable because a lot of times when you change to a larger unit, you end up with fractions and the manipulation becomes a little messy. But here in the metric system, it's pretty easy. Suppose we do it by changing to kilograms first. I'm going to do it both ways here for you just to show you, but suppose we're doing it in terms of the kilograms first. Right? Now, to do that, we're changing 300 grams into kilograms. So it's 300 grams is how many kilograms? So we go through that little thought process, and it works very fast. We're going from a smaller unit to a larger unit, fewer of them, divide by the number of grams in a kilogram, that's 1,000, divide by 1,000, decimal slides 3 over, 0.3. All right, now the amount of fertilizer per tree is 0.3 kilograms, and we have 400 trees. So what we're doing is multiplying 400 trees times this amount of fertilizer per tree, and multiplying, let's see, I'll get 0, 0, 4 times 3 is 12. I have one digit to the right of the decimal here. I need one digit to the right in the answer, 120. So that means that we need 120 kilograms then of fertilizer. All right, let's do it working in terms of the gram and see what the difference is. Now, if we're just staying with this 300 grams per tree, 400 trees, then we would be doing this. It would be 400 times 300 grams. You see, 400 trees times 300 grams for every tree. So we've got, let's see, the fast way to do this is to let these zeros just carry down. Now, I could show it as a long division problem, but the quick way is just 0, 0, 0, 0 is going to be, those are the right digits in this product, and then 4 times 3 is 12. So we have this, and so we have 120,000 grams. And now we need to change this into some number of kilograms. You see, so how many kilograms do we have? Well, again, grams into kilograms, we're going to a larger unit. There'll be fewer of them. We divide by the number of grams in a kilogram. That would be 1,000. Dividing by 1,000 slides the decimal from this point to that point. So we have 120.000, or 120 kilograms as the total amount of fertilizer as expected.